All right, welcome back to week 2 of experiment 3 on the synthesis of, or we're going to take our pseudo-ionones and we're going to make the ionones. So this will be the cyclization week. And we're going to hop over to Christin. And Christin, why don't you tell us which cyclization or where you are at, what you have set up, and which cyclization you're going to be doing.
So I'm doing the cyclization with phosphoric acid, and this is the product from week 1. So I just went ahead and got 1.41 grams because it asked for 1.4. And then in my 25 milliliter Erlenmeyer flask in the water bath, I actually already have my 4 milliliters of concentrated phosphoric acid. So my next step is to just slowly and drop-wise add my pseudo-ionones to my phosphoric acid. So what I'm going to do is just go ahead and get a little bit, and I'm just filling up like the tip of my pipette. I don't get very much, and then I'm just going to go ahead and go here and start slowly and drop-wise adding. As you can see, there's a very fast color change and a very strong reaction, which is why we're trying to go nice and slowly. So I will just continue to add this for the next 20 minutes until I have all of my pseudo-ionones added to my phosphoric acid. And then I will stir it for another 20, and then we will continue with the experiment.
All right, we'll be back in 20 minutes. All right, so we're back to the drop-wise addition into the phosphoric acid. And here you can see kind of the final color change here. It's this nice dark red color. It's definitely gotten a little bit thick. At this point, Christian is going to let this stir for another 20 minutes at room temperature. And now we're going to jump over to Jerah. All right, Jerah, why don't you tell us which cyclization you're doing and what you've got set up here.
Okay, so slightly different than what Christin's doing. The only changes that we have is we're doing 2 different acids. I am doing the sulfuric acid with glacial acetic acid. And so right now, I'm gonna add in our product from week 1, about 1.4 grams, into a already pre-mixed glacial acetic acid and sulfuric acid stirring in an ice bath.
It's kind of hard to tell from the angle, but it looks like yours is turning a nice dark red color as well.
Yeah, it's very, very dark. I will give you a better view here in a second.
That's fine. You have to drop-wise for, what, 20 minutes, right?
Yeah, so it's going to be a while. So what I can do is show you. Oops.
Yeah, we can see that.
Cool.
All right, so we will come back to you as soon as your drop-wise over 20 minutes is done.
Cool, sounds good. All right.
All right, so Jerah has finished the 20-minute drop-wise addition, and this is the result. He's just now taking it out of the ice bath, and it's going to stir at room temperature for another 20 minutes. You can see the color is this nice dark red, and if Jerah kind of tilts the vial a little bit,
yeah,
you can kind of see how viscous it has become. Maybe tilt it the other direction so the bottom's kind of gunky. You can see it's kind of turned into this nice dark syrup now. So now we're going to go ahead and stir this at room temperature, and we're going to go check up on Christin, and I think she's going to get ready to do her workup. All right, we're back to Christin, who's ready to do the workup of the cyclization with phosphoric acid. Why don't you tell us what your setup is and what you're doing?
So after the 20 minutes of slowly dropping in the pseudo-ionones into the concentrated phosphoric acid. I let it spin for another 20. And then what I did was, it was a very, very dark black. And then I had to get 30 milliliters of NaCl. As you can see, there's still some left in here, but I've added the rest of it to my product in that 25 milliliter Erlenmeyer flask. So what I'm going to do is go ahead and put this into the separatory funnel first. And then, as you can see, there's a lot of gunk still left in there that I will probably want. So I'm going to go ahead and add the rest of the NaCl to the flask again. And then just stir it around. And it looks like when I'm stirring it around, it seems like everything that's left in there isn't actually soluble in sodium chloride. So after I add this part, yeah, that's still all just solidly stuck to the side. So my next step is going to be to grab the BME that we used in week 1, and I'll be adding 15 milliliters of that to my flask again. Okay, so I now have 15 milliliters of BME in here. And I think I'm going to actually add it in 2 sections to try and get the most of my product that I can. So I added about half. I'm going to go ahead and swirl as much as I can. And you can see that a lot of it is coming off the sides. It already looks a lot cleaner than it did before. So it's definitely soluble in my BME layer. So again, I'm just going to keep spinning for a little bit longer because I can see that there's still some things stuck on the bottom. Okay, and then I'm going to go ahead and add that to the same separatory funnel. And if you look closely, it's pretty hard to see in the video, but I'm actually beginning to see 2 layers. The first one ends about here, and then this top section actually looks a lot clearer and more like a yellowish orange, whereas the bottom looks like a very thick red-black color. So then my second half of my BME addition, just go ahead and add that, and then spin around, and you can see there's still stuff dissolving in there, which is why it's turning that kind of yellowish reddish color. So fortunately, I can't get very much of the stuff that's at the very top because otherwise my solvent's probably gonna fall out of my Erlenmeyer flask. So I'm just gonna go ahead and try to add it slowly to try and get as much as I can. Okay, and then as you can see, I definitely got a lot of that stuff that was stuck on the side of my Erlenmeyer flask, which is very good. So hopefully everything that I want has been transferred over to my separatory funnel. And now I'm just gonna go ahead and get the cap for it. So here we go, just put it on top, and that way, take it off. And I'm just gonna go ahead and invert. And then I wanna go ahead and vent it. I heard a little whoosh of air, so I vented. So go ahead and close it again. And then just do it. Just to be as thorough as possible, I'm gonna go ahead and do this 3 times. So second venting, done. And then just invert. And then And since I'm still seeing a lot of stuff right here, I'm actually just going to go ahead and do it one last time. Oops. And there, I forgot to close the top, which was definitely not good of me. And I lost a little bit of product right there, which is why you should be very careful and always remember to close it. So then last time. And you can see that most of the stuff that was on the sides here has been, it has gone into solution, which is what we want to have happen. So I'd say that that is well mixed enough. So I'm just last time venting, close it and flip it over. And then go ahead and stick it back into here. And then take off my cap, and I'm going to go ahead and let it settle for a second, just so I can see those layers nice and clearly. And while that's settling, what I'm going to do is go ahead and grab the solvents I need for my next wash. Sorry, actually what we're going to do is we're going to extract twice with 15 milliliters of BME. So I'll just go ahead and fill this up with another 15 milliliters for the next extraction. And then since after the next extraction, we'll be doing 2 washes and I don't need the BME anymore, I'm going to go ahead and put it back into the solvent hood. Okay, and then unfortunately when I spilled a little bit, I actually got some onto my organic beaker, so I'm just going to grab a new one right now. Then I'm just going to go ahead and label this one with organic. There. Okay, so then I'm going to go ahead and now that we see that nice separation, it's a little bit less clear in the video, but what I'm looking at is a solid like orange red right here in this layer, and it's much more opaque. I can see through it pretty well, whereas up here there's very solid like brown-ish looking layer, which is going to be my organic layer. So I'm going to go ahead and take out my aqueous layer into my aqueous beaker right here. And then again, I can go a little bit faster during the beginning part. And once I get closer to that organic layer, I'm just going to go ahead and slow it down. And then since it's coming out a little bit crooked, I'm actually going to go ahead and lower this right now to make sure that it doesn't spill out of my beaker. So just lower it. And then I'll continue going a little bit slower now that I'm getting so much closer. Okay, and now that I don't see any more of my aqueous layer in there, I'm going to go ahead and switch out my beakers so that I have my organic layer underneath it. Put that there, and then I'll go ahead and run. Yeah, then I'll go ahead and take out my organic layer since we're going to wash the aqueous layer again. So I'll just take this out and move it to the side until I want to combine my layers. So I'm going to let that drip out for just a few more seconds. So I'll go ahead and leave that right here since there is a couple more drops right at the very tip. And make sure it's closed because now I'm going to go ahead and add back in my aqueous layer. And try to get that last drop, and then I'll take out my organic beaker and switch it over to my aqueous once again. And then I'll take my second extraction of 15 milliliters of BME and add that to my separatory funnel containing my aqueous layer. And then already you can see that there is a very clear distinction between the aqueous and the organic layer. And it looks like most of our product came out in our first extraction, but there is still that big yellow color, so there's probably some more in there. So it's good to be thorough and do that second extraction to make sure you get everything that you can. So I'm just gonna go ahead and invert. And then vent. And this time, since there's less stuff that wasn't soluble, I'm going to go ahead and just do it twice probably. So it's to be my second inverting and venting. Vent, and then close. I'm gonna go ahead and put it back into the support ring and take off that cap. And again, while it's settling, I'm going to go ahead and grab my next solvent, which in this case, I'm going to use 15 milliliters of 5% sodium carbon dioxide, I think. What is it? Sodium
carbonate?
carbonate? Is that what I'm using right now?
Yeah, sodium carbonate.
Yes, okay, thank you. The 5%.
Might be bicarbonate.
I think it's just carbonate. Is it in 10% sodium chloride?
Yes.
Yes, okay, in the 10% sodium chloride. Sorry, I don't have
sodium
time.
bicarb, Christin.
Oh, it is? Oh, yep, you're right, it is. Sorry, I don't have mine in front of me right now, so I was just kind of guessing. It's 15 milliliters. It's 15 milliliters.
That was good though.
Okay, and now that I have my next solvent, it looks like those layers have separated quite nicely. You can see pretty clearly those two layers. So again, I'm going to quickly get rid of the beginning of that aqueous layer until it gets closer to my organic. So now I'm just going to go ahead and slow it down a little bit. Okay, and now that I don't see any more of my aqueous layer in there, I'm going to switch it on over to my organic extracts from last time. And I'm going to go ahead and combine this layer with it. Okay, and then my next step will involve my combined organic layers, and then I'll wash that with my sodium bicarbonate. I'm just going to go ahead and double check that's closed, and then go ahead and add back in my organic layers. I'm going to go ahead and stick my waste beaker underneath in case anything spills. And then I'll add my solvent. And I'm not sure if you guys can see this in the video, but I am seeing a fair amount of bubbling happening, and it does seem like some of the product from here is actually going up into the top layer, which is good. It's nice to see that separation happening. But since there is still a fair amount of bubbling, I'm going to just wait a second before I invert and vent. Okay, it looks like it is good now. So stick back on the cap, take it out. Now I'm just going to go ahead and invert. I heard a nice little pop of whatever gas was being created in there, so there's no more vapor pressure within my separatory funnel. Then I'll probably just do it once more. Okay, and then I have vented, so just close it. I'm going to go ahead and stick it back into my support ring and take off the cap and let my layers settle. And then once again, I'm going to take this chance to go ahead and get my 15 milliliters of sodium chloride. Okay, so I now have my next one, which I'm going to put to the side. And then looking at this, it looks like it's actually still settling a little bit. If you see, there's still some movement right here, where I'm actually seeing some of the top layer coming down a little bit. So I'm just going to wait another minute or so and do some moving around just to declutter my area. What's actually interesting about what's happening right now is I'm not sure how clearly you guys can see it. I'll try to bring this a little closer so you can. I'm actually seeing a little bit of a third layer right here, which could either be a little bit of leftover previous solvents used, or it could be things settling out into the separate layers. But
It's more than likely just the emulsion layer slowly separating out.
okay. I was wondering, it's just moving so slowly. Is that just probably whatever wasn't soluble is kind of moving? Okay.
So as you bring it down, it'll kind of help that emulsification kind of re-separate out. You can just get rid of some of the, just get some of that aqueous washout, that bicarb washout.
Yeah, actually that's already looking better. Okay.
So I can't see very well from this end, but I mean, it looks like it's pretty much separated out.
I think it's as separated as it's going to get. It doesn't seem to be moving at all. It just has that little band, but I think that's totally fine.
Yep. Go ahead and get rid of the aqueous and then wash with the brine.
Okay.
Or not brine in this case, but 10% sodium chloride.
Get that with this. Okay, adding my almost brine. Okay, here we go. Ooh. Okay, that looks good. wanted any pH paper.
Yeah, this one's stuff is dark.
It looks
Oh yeah, it might just be a emulsion layer. That
Yeah, look
stuff
at
takes
that.
forever.
I know. Oh,
Looks cool
always-
though.
always
When it comes down to it, it's all about how cool it looks.
That's all that matters. Mhm. Okay. Mhm. Okay, so while I'm waiting for that to finish up to see if I can get anything more out, I'm just going to check the pH before I throw out my aqueous layer.
So why are you checking the pH of the aqueous layer?
Because I want to make sure that it's basic before getting rid of it. Just to make sure that I am getting rid of the right layer. Okay. Okay, and it looks good. I'm just going to go ahead and put that over to the side. Go grab my organic layer. Okay. I didn't see any more emulsion, so I'm just going to go ahead and put all of my organic layer into my beaker. Okay, and then I still have some magnesium sulfate left over from before, so I'm going to go ahead and use that in my organic layer to go ahead and dry it. Since there's not very much, I'm just going to pour all of it in there. And then swirl it around and look for that snow globe effect and see how much it's clumping. And so that actually looks pretty good. If I spin it around, I am seeing loose pieces and everything going off by themselves, and it's not just staying in one big chunk. So I'm going to say that that looks good. And then I'm just going to go ahead and set up my filter. And I'll be ready to gravity filter with my glass filter and some cotton into a pre-weighed round bottom. Okay.
All right, so we're back, and Christin has added the mag sulfate and is going to get it into a round bottom.
And I'm just stirring it up a little bit to try and get as much of that mag sulfate to get into the filter, just get as much of my product as possible. So I'm just pouring it over that cotton that I packed on pretty tightly, so it will take a little bit longer to filter through that. Oh, it smells like straight rubbing alcohol.
So we'll come back as soon as that's done filtering.
Yeah.
All right, so now we're at Jerah's reaction, which is the cyclization with sulfuric acid, and he's going to start his workup. Why don't you talk us through this workup, Jerah?
Okie dokie. So this has been stirred for roughly 20 minutes at room temperature, and we're going to add some ice cold water and the BME, the organic ether. I'm going to go ahead and add that to my solution. And I'm just stirring it like this because it's easier to stir smaller volumes. All right. Okay, let me grab the secretary funnel. Alrighty, so we have that. Okay, so now that we've added that, I'm just going to use my little handy dandy magnet here.
When
There's
you have a
stir
chance,
bar.
Jerah, if
Yeah.
you can reposition the camera just up a little bit.
Totally.
Whenever. That's better. Thank you.
Cool. All right. So I made sure that the stop clock is closed, and I'm going to go ahead and add in our solution to the top. And yeah, it's going to be really mixed up. So we're going to get some emulsion. So it might take a little bit for that to separate. All right. And so right now we're just letting it separate. We have the aqueous layer at the bottom. We have our organic, our tert butyl methyl ether at the top here. You can see most of the colored material has migrated into the BME layer. And we're going to do one more wash with 6 milliliters of BME. And I'm going to add this to my original Erlenmeyer because we can tell that it's dirty and there's still a lot of product inside of there. So just one more way to get more of our material. So I'm going to keep that for the second extraction. And if you want, we can pause it just for a little bit and let it sort of settle.
It looks like it's good enough to to go ahead and separate now,
Okay.
and then you're just gonna wash that
Yeah.
aqueous layer with more of the organic.
Ready? So I'm going to capture the organic layer. And then I'm just going to turn around, put the aqueous right back into the top. And I'm adding my 6 mils of BME. All right. Allow the 2 layers to interact, find their equilibrium. Okay, I'm just going to let them separate. And then one thing you can probably see is the organic layer is very clear, and then the aqueous layer is very cloudy.
Go ahead and separate those when you're ready.
Ready? Alrighty. So I'm going to mix these 2 together. So we're organic layers. Alrighty. Right back into the top. And one thing to remember is that this was originally glacial, which is like pure acetic acid. So it's glacial acetic acid and concentrated sulfuric acid, so it should be very acidic. And what we have here is a solution of 10% sodium chloride and sodium bicarbonate. So the sodium bicarbonate is the base. That'll help to neutralize the pH. And the sodium chloride solution is kind of what we did before, where it's a concentrated salt solution that it itself absorbs water. Okay. And yeah, so I'm gonna do 2 washes of 12 milliliters. Okay. And the only reason I put it in this original flask again is just one other tiny, step to possibly bring more stuff that was on the surface back into to our solution. We can gain more product that way.
Hey, Jerah, since you are mixing acids and bases, when you do the inversion of the set funnel, make sure to vent after that very first inversion. It's going to build up a lot of gas right away.
Definitely. But thank you for the reminder. That would be a bad, a bad thing to forget. So I don't know if you can tell on there, there's quite a bit of bubbling that's happening now. So what I'm gonna do at this moment is just wait until I see at least bubbling stopping here, and then I'm gonna do an inversion.
That could take a while. You could try swirling it a little bit just to kind of mix things up and help try to quench some of the acid.
Well, it actually looks pretty good. Okay, so I'm gonna invert here, open that up. There was a small bit of get pressure built up. We'll do the same thing. Even more pressure. Because we expect gas, I'm being extra gentle. So I'm still hearing some pressure built up. Do a couple more
So
times.
after this, Jerah is going to repeat this. He's going to wash again with bicarb and salt solution. And he's going to repeat what Christin did earlier, where he's going to dry it with mag sulfate and dry it down. And we'll come back to when it's dry and see what his product looks like.
Sounds good. I'm ready.
All right, so we have both of the products now dried down and in their round bottoms. So you can give us a close-up on those, Jerah.
Okay. We have both of our products in my right hand here. See, it's a very dark, thick product. This is the phosphate product. And we have over here is the sulfate, or the hydrogen sulfide, sorry, the hydrogen sulfuric acid, thank you, product. And it's a little bit lighter in color, which is actually surprised, but it could just be the thickness of them. So those are the two products.
Great, and you're going to show us how to take the UV-Vis of one of them?
That is correct. Okay, so this is the UV-Vis. And we're just measuring.
Go ahead and just pull that paper out, yeah.
Ah, cool, thank you. So we're just measuring between 200 and 400 because of the peaks that we're interested in. But before we do that, we need to background subtract our solvent, which is our blank. And so I already have those prepared here. These are both nearly 100% ethanol. And inside of this UV-Vis, it happens to have 2 spots. Not all UV-Vis will have 2 spots, this one does. And the reason being is it can measure a reference sample and your sample at the same time. So let's go ahead and measure the blank. So user baseline, start. Maybe something I didn't do, which was I should be wiping down. I'll show you that on these cuvettes. You'll notice that these cuvettes have one side that's totally clear and the other side is opaque. And so as you can imagine, the light is going to go through the clear side. So you want to make sure that doesn't have any smudges or dirt on it, because that's going to effectively absorb or diffract the light or refract the light in a way that's going to change how our spectrum looks. So right now, yes, we're just measuring the baseline, which is pure ethanol. This is our blank. Okay. And like I said, this instrument has 2 spots, one that's a reference sample and one that is the sample of interest. So I'm removing the sample, one of the blanks, and replacing it with our sample of interest. This here is our sulfuric acid product. So I'm going to enter that in there. And then now that I'm set, I go ahead and hit start. And it's currently scanning, starting at 400, and it's scanning all the wavelengths.
Maybe you can zoom in on the computer screen a little bit. It might fluctuate a little too much. We might not actually be able to see anything. You can kind of see it through the refresh a little bit there. You can see the peak just slightly going up, starting to absorb some light. And then it's going to go ahead and print that out for us. Hey, that looks good, Jerah.
Cool. All right.
All right, and that concludes week 2 of this lab. All other data will be posted, hopefully, to Canvas very soon. All right.
Sounds good.
Thanks, Jerah. Bye.